to meet you again. Today we will solve problem number 23 of our MATLAB problem list. And in this problem, we want to approximate the value of pi by evaluating the following sum. So the idea is to approximate this series, multiply it by 6, and then compute the approximation of pi by computing the square root of the result. Obviously, we cannot compute this series because it contains infinite terms, so the idea is to approximate it by just accounting for the first n terms. So in the first part of the exercise, we will develop a MATLAB script that, using the for sentence, evaluate this approximation and also the error of the approximation. Finally, it asks us to compute how many correct significant digits do you obtain using 200 terms in this area. Okay, so what we will do is to start our MATLAB session. Okay, first of all, we will set our default folder. That is, in my particular case, I will select the desktop. Okay, and inside desktop, I will create a new folder called exercise number 23, x23. And I set this folder as my default or my working folder. Then I will create a new script and I will write the first sentences that we always suggest to be clear in order to clear the workspace each time we run the code, and CLC in order to clear the command window each time we run the code. So after that, I will write 2 command lines, and this will be part 1 of the exercise. So the idea is to compute the series using 200 terms. So then we create a variable called numTerms, which will be equal to 100. Then we will loop on the number of terms, and we will add each term to a counter, to a summation. So that we will create a variable called sum, which is initialized equals to 0, and then we will loop for I from 1 to numTerms, and then inside the loop what we will say is set sum equals to the all value of sum plus, and then we will add the ratio 1 over I to the square. That will be the summation, and then we will approximate to the square, and this will be the approximation, and finally we will compute the pi approximation, we call that pi approx, as the square root of 6 times the summation. That will be the approximation, and then we need to compute the relative error. So the relative error will be the ratio between the absolute error of our approximation and the exact value of pi. So that will be something like the absolute value of, and inside the as input parameter of the function apps, we will write the difference from the pi approx and the exact value of pi, that is the absolute error, right? Now divided by the exact value of pi. Then we have to compute the number of exact digits. So to do so, what we will compute is, let's call that value q, and that will be the 4 of the logarithm in base 10 of dot 5 minus the log in base 10 of the relative error. And finally, we will write on the screen that this is the end of part 1. Okay, so please note that we do not write a semicolon at the end of these 3 sentences, so the result will be written in the command window. So let's try to run our code, and first we have to set a name for the file. That will be exercise23, for instance, and we save the file before running it, and here we get the result. Using 200 terms, we get an approximation to pi equals to 3.1368, and the error is 0.0015, and the number of exact digits is just 2.